Faraday's laws of electrolysis. Michael Faraday put forward two laws that explains electrolysis. Okay, one is the first law, which states that the mass of substance, the mass of what? Substance or elements. That substance is basically elements. The mass of substance or element discharged or deposited or liberated during electrolysis is directly proportional to the quantity of electricity passing through the electrolytes. In fact, it summarizes all we have said so far. It summarizes it. We want to find out that each time a substance, a chemical substance is discharged, we want to find out the mass of the substance discharged, or the current that was used to derive the mass of the substance, or the time taken to derive it, or the chemical equivalent that also plays a vital role in the chemical process. These are the things Michael Faraday was trying to explain. So when we talk about electrolysis, we can't talk about electrolysis without mentioning Michael Faraday. He just put forward two laws to explain all these mechanisms, one after the other. Okay, so looking at this mathematical statements of all this we have said. Okay, putting it in this perspective, we have that just like in that statement, in that word statement, that the mass of elements discharged. The mass of element discharged. Look at the M there. Mass of element discharged is what? Directly proportional to what? Quantity of what? Currents. Current is that electricity that was passed. But this is like more summarized. Okay, so we just summarize that 4-line definition or 5-line definition. Mass can be measured in kilograms or what? Grams. Quantity is measured in what? In coulombs. Are you with me? So what this thing means that as the mass of as quantity of electricity is increased, mass of substance discharged will also what? Increase. That's what this statement is trying to say. And if we call it equation 1, suppose we call it equation 1, remember that quantity Q is a product of what? Current I times what? Time in seconds. Time in what? Seconds. Are you with me? One can call this what? Equation what? 2. Are you with me? Or depending, I can just, okay, it's okay. I can just go back to equation 1. I said, okay, I can't always keep this thing like forever. M will not always be very proportional to, there must be kind of the changes that may occur in future reactions that is not always be like this. So what if I want to keep a check on this and taking away this proportionality sign here and maybe introducing an equality sign, what is going to happen to this equation here? I'm going to introduce what? A constant, which is what? Z. I will know that Z is a constant. Let's call electrochemical equivalent. Okay, a constant of proportionality. Okay, and I'll say what? Q. Are you with me now? I can call this what? Equation what? 2. Sorry, equation what? 3. Then I'm going to do something here. What if I'm to put equation? What if I'm to put equation 2 or equation 3? Okay, into equation what? 2. Do you know what I mean? That means anywhere I see Q, I will now say is what? IT. Therefore, and I have M is equal to what? Z times what? I times what? T. This is what? Equation what? 4. This is Faraday's first law. But it is not complete. But one can say M equals to ZIT. It's Faraday's first law. But you are not complete doing that. So what do? I have to state emphatically what is this Z? What is this proportionality? This Z, which is a proportionality or constant of proportionality called electrochemical equivalence, is just relative atomic mass of the element divided by the what? Valency or charge. This is the valency. Okay? Multiply by what? A Faraday. Of course, you know what's Faraday? 1 Faraday is what? 96 watts. Oh, the card is quite, it's like if. Let's say Faraday is just 1. This is 1. And this is 2, 1. Now you look like if Faraday. You know what I mean? Like if equals to, you know, it doesn't make sense. So let's, Faraday, just 1 light is what? 96 watts, 500 watts, coulombs. Let's call this equation what? 5. Now, when you say this is constant, now listen to me. Now, assuming you are looking at copper, the relative mass, atomic mass of copper is constant value, it's very constant. Like you have 63.5, it's not going to change anyway. The valency of copper, the charge on copper is what? 2. Faraday still remains what? 96. So this is what Z is all about. So I'm going to do something to now get the complete Faraday's first law, the very complete Faraday's first law, by putting equation 5 into equation 4. Do you know what I mean by that? Anywhere I see Z, I'll not say it is this. Therefore, I'll not say that M is equals to, if I'm saying Z, I'll not say Z is what? R A M over what? C F times what? I times what? T. So are you with me now? This is equation 6. This is Faraday's complete. Faraday's, how would I put it? Faraday's first, or complete Faraday's first law. Put it that way. Complete. Equation 6 is complete. Faraday's first law equation. Okay. RAM is relative atomic mass, Z is charged or C, F is Faraday, okay, I is current, T is time, Q is what? Quantity. Note 1 Faraday is equal to 1 mole of an electron and has a value of what? 96,500. So this is complete Faraday's first law equation.